In this tutorial, I will guide you through calling an API using the 4D.http request class to generate data for users. Let's start by creating a new sandbox. Click on Create New Sandbox and choose a template for your app from Qodly's suggestions. Select the CRUD app template. Once your app is created, click on it. Then, hit the Studio button to enter Qodly Studio. In the preview, you will see two buttons, Generate Data and Go to Demo. Our goal is to generate data using the API, then view the results by clicking Go to Demo. I will click on Go to Demo. If you notice, no data is displayed. We need to generate data first. Let's begin by exploring the app's data model. It consists of two main data classes, user and address, each with its own set of attributes. These attributes will be populated with data generated by the API. To generate the data, we will create a function called getUserData in the class DataStore. This class is extended from the DataStore implementation, allowing functions to be applied across all data classes. So, we will use the HTTP request class provided by Qodly. It allows you to manage HTTP requests, enabling you to configure and send requests to the HTTP server, as well as processing the response. You can create and send HTTP requests using the 4d.httprequest.new, which returns an HTTP request object. After inputting the API link, use the .wait function to await the server's response before proceeding with the execution. Also, remember to declare the variable request with the type 4d.httprequest. So here is the logic. If the response is not null, we will start mapping the data. Otherwise, we will display an error message indicating a problem with data generation. In the API link, you will notice that I have specified results equal to 10, indicating that I want to retrieve 10 records from the API. Let's open the link to view the API data. The results variable represents the collection of data we receive from the API. The JSON file received showcases a person information but may not be visually structured. I use a tool to purify the JSON file for better understanding. So, copy the URL and paste it into the tool. As you can see, the file is now more legible. In the results collection, we find one or more objects, each encapsulating a person's specific details. For instance, the name object holds information about the person's name and related details. Now, let's initiate the mapping process as follows. Create a variable of type collection to store the results. Iterate through each object in the collection using a loop and map its attributes. Declare the variable item of type object that represents each item in the collection. Let's begin with the others data class. create a variable called address with the type entity and instantiate a new entity. Proceed to populate the street attribute. So referencing the JSON file, locate the location object containing the street details. Extract the number attribute from the street object. So here is the action: item.location.street.number. Continue mapping other attributes in a similar manner. Declare an info object to check if the save succeed. Next, let's move on to fill in the user attributes. To do this, declare a variable named user of type entity. Now, we can begin with the first name attribute. So based on the JSON file, we're going to put item.name.first. And we will continue in the same manner with the remaining attributes. Now, let's address the need for an avatar to populate the avatar attribute in the user data class. Begin by creating a request for the avatar and access the picture object in the JSON file using item.picture.thumbnail, as we will see on the JSON file. Obviously, type .wait to await the server's response. Don't forget to declare the request avatar, variable of type 4d.http-request. So, if the response is not null, proceed with mapping. To handle the avatar image, we will use the blob to picture command, which inserts a picture stored in a blob into a Qodly picture variable, regardless of its original format. This command takes two arguments: the body of the response from the request, likely containing the image data, and a variable to store the converted image data after using blob to picture. Declare the image variable of type picture. Finally, assign the converted image to the avatar attributes of the user data class. If an error occurs, display an appropriate error message. Set the user's address to a specific location. Save the data and display a confirmation message indicating that the data was generated successfully. We have completed the function. Now, let's integrate it into our web form. Follow these steps. Navigate to the home web form. Click on the Generate Data button that will trigger the function we just created. Open the Events panel. Click on the Add New Function icon in the OnClick event. Set the name of our function and activate the feedback feature. Save all changes and click Preview to view the results. Now hit the Generate Data button. An error occurs. Let's activate the debugger by clicking on Debug. Next, we will trace the line where we assign the request to the request avatar variable to pinpoint any issues. And click on the Generate Data button. Return to the debugger to review any errors. In this case, the problem occurred in the line of request avatar. So, I declared the variable as type collection instead of type for the .http request object. Let's review the results. As you can see, the data was successfully generated, and the API provided 10 records as requests. All the data is populated correctly. Perfect. Remember to delete the generated data to prevent data redundancy in subsequent executions. Great job! You have completed these steps to call an API with Qodly. Thank you, and stay tuned for more Qodly videos.